Now the question arises that the growth rate, which is used in the perpetual growth dividend discount model, how it is computed. So there are a few approaches to find that growth rate. Number one, we can use the data of the dividends of the company from the past and can find its average growth rate. Or we can also use the industry median or the growth rate the dividends have been paid by that industry and see that how it is growing. The third approach is sustainable growth rate. Over here, we will study the first approach, that using the company's historical data on the dividends, and the sustainable growth rate. How can we compute the growth rate? So, for example, there is a company, and they have given this dividend in the past. In 2008, $1.5, 2009, $1 and 70 cents, all the way in 2013, $2.20. So we will see that how they are growing and simply take their average. So this is the arithmetic average, right? So in the Excel, you can see over here that I have simply computed the growth rate 1.5, which is the 2009 dividend, minus the previous year dividend, which is 2008, 1.5 divided by 1.5. So I got the 13.33% over here. So then for 2010, I again found the growth, that how in 2010 the dividend grew compared to 2009, because it is $1.75 in 2010, minus 1.7 divided by 1.7. So in this way, I computed the growth rate of this stock, dividend of this stock over the 5 years. Remember, you need 6 years in order to find the growth of 5, because you need to have a base year compared to which you have to find the growth rate. So there are 6 years, but we are able to find the 5 growths over here. And finally, we simply take its average, all the average of these 5 growths. So the arithmetic average turned out to be 8.05%. The other way is to get the geometric average, and the formula for that is actually very simple, and most of the analysts actually use geometric average to find the perpetual growth of a stable company. So over here you have the dn raised to the power 1 by n divided by d naught raised to the power 1 by n minus 1. So what is dn? Dividend at the end of the nth year. So over here n is the last period 2013. So dividend over here is 2.2 raised to the power 1 divided by n. So how much n is there? Apparently it seems it's 6n, but it is actually 5n. Why? Because 2008 dividend has already been paid. So how the dividend is growing from 2008 to 2009, it means 1 year. Then 2009 to 2010, it means second year. 2010 to 2011, third year. 2011 to 2012, fourth year. And 2012 to 2013, fifth year. So there are, the n is actually over here is 5. So dn means 2.2 raised to the power 1 divided by 5 whole divided by dividend, which is right now 1.5 raised to the power 1 divided by 5 minus 1. If you do this calculation, you will find the geometric mean or geometric average or the of 7.96, that how dividend is growing over this time period of 5 years from 2008 to 2013. This is one way in which we can find the growth rate, which can be eventually used in a perpetual growth dividend discount model. As I mentioned earlier, the analysts usually use geometric average in their calculation. The second way to find the growth is sustainable uh, growth rate. So the sustainable growth rate we can calculate by multiplying the return on equity with the retention ratio. How much percent of the earnings per share we are retaining after paying the dividends, right? So return on equity is simply the net income divided by the equity, and the payout ratio is simply the proportion of the earnings of shares paid out as a dividend. So the retention ratio is simply then 1 minus the payout ratio. Usually we have a payout ratio. That's why we calculate payout ratio and subtract it from 1, meaning that how much percent of the the earnings per share we are retaining within the company. We multiply it with the ROE, we'll get sustainable growth rate. So for example, there is a company DTE Energy Corporation, and it has a return on equity of 10%, and the projected earning per share is 4.05 and had a dividend level of 2.35. So first of all, we have to find the payout ratio. We simply divide 2.35, which we are paying, out of 4.05, which is the overall earning per share. So it turned out that 58% of the earnings per share the company is paying in the form of dividend. And how much obviously they are retaining, then it is 42%. 1 minus 58%. So the sustainable growth rate is simply then the return on equity, 10% over here, multiplied by the retention ratio, which is 42%. In decimals, percentage, 42% means 0.42. You multiply the percentage with 100 to come to the decimals, right? So 0.1 multiplied by 0.42, it will generate 0.042, and again, in order to convert the decimal back to the percentage, you have to multiply it with the 100. So you'll get 4.2%. So the sustainable growth rate is 4.2% using this approach. So for the DTE, using the same data where the dividend was 2.35, you can see that over here, 2.35 multiplied by 1 plus the perpetual growth rate, which we this time found with the sustainable uh, growth approach by multiplying return on equity with the retention ratio, divided by the required rate of return minus again the sustainable growth rate. The price of the share turned out to be 445.2. So this could be very surprising, because with the previous approach, the price of the share turned out to be only 80, like $7 over here, $87 if you use the growth rate 2%. So finding the appropriate growth rate is very important. It's a very, very big assumption. And you as an analyst, we have to be very careful in finding the growth rate. We have to justify this growth figures, that why we are using a particular growth rate. Obviously experience plays a big role when we will be working. The experience help us that what growth rate is appropriate. But you can see that if there is a little bit like wrong assumption regarding the growth rate, the price of the stock will be very much different. And mathematically, if we see that why this is a very big price, because the difference between the required rate of return and the growth rate is relatively small. In the denominator, when the denominator is not a big number, it's small number, then obviously numerator will the final answer will be very big, because the numerator will be getting divided by a very small number. Now let's analyze the return on equity, because return on equity is a very important part of the finding the sustainable growth rate. So the return on the growth rate can be increased either by increasing the retention of the earnings per share or increasing the return on equity. Remember, the formula was return on equity into the retention ratio to find the sustainable growth rate, which can be eventually used in the perpetual growth dividend discount model. So the manager can increase the sustainable growth rate by decreasing the dividend payout ratio. In the first step, simply increase the retention ratio, in other words. So when you are paying less dividend, obviously you are increasing the retention of the earnings of the share. The number two is we can dis or expand this return on equity into three portions, right? And one is the profitability. How much percent of the sales we are saving after paying all the expenses? So this we can remember. Return on equity is actually the net income divided by the equity. So if you have net income divided by sales multiplied by sales divided by asset divided by equity, you have effectively the same net income divided by the equity, because the sales in the numerator will cancel out with the sales in the denominator, likewise the assets. So the first portion is the profitability, as I was telling, that how much percentage of the sales the company is saving in the form of net income after paying all the expenses and depreciation, everything. So if this number is say 20%, it means from every $1 which the company is generating as a sales, 20 cents they are saving as the income. So this is the final saving which they have after paying all the expenses, even the taxes. The second is the asset turnover, that how effectively we are utilizing the asset. If the company has so much asset but they are not able to generate the sales, it means these assets are sitting idle there. So if this number is say 8, it means each dollar worth of asset is generating $8 in sales. Higher this number, the better it is for the company, because the company is using the given resources or assets in assets to generate a lot of sales, and then obviously from that sales they will be able to generate the net income. So higher the sales means that the company has more opportunity to generate the net income. So the asset efficiency is the second key component when we have to increase the return on equity. And the last one is the equity multiplier, which is also called assets divided by the equity. So if you have a lot of asset but very less equity, it means you are using the debt holders' money to get the assets, and from those assets the company is generating the sales and eventually the net income. So the company is using someone else money to generate its profitability. So if the asset is high relative to the equity, so in other words, if we are increasing, the company is increasing the debt, this is another way of increasing the return on equity. Now, after like looking deeply into the return on equity, we are going and moving forward to the two-stage dividend discount model. And it seems like a very complex formula, but it is not actually complex. The thing is this, that we have a situation where we can say that, okay, for first few years, say 5, 6, or say 7 years, the dividend is growing at a certain percentage, say 10%. But Once this, let's suppose if this is an IT company, in the start might be the growth is very aggressive, 10% growth rate for first 7 years, and then might be a saturation hit the market, and the competitors have arrived. It is not feasible for the company to increase its dividend at the same aggressive 10% rate. So might be after that the growth has declined, and now the perpetual growth is 5%, with which the dividend will grow forever. So for first T years, again 5 or 6 or 7 or whatever years, there is a certain percentage, and then after that the growth rate changes. In such situation, we have a two-stage dividend growth model, right? So in this particular example, in fact, slide, the first T years growth rate is G1, and thereafter the growth rate becomes G2, and this G2 is the perpetual growth rate by which the dividend will grow forever. And for the perpetual growth model to apply, remember, your growth, which is G2 in this case, have to be less than the discount rate. Otherwise, we cannot apply this second part of this formula, two-stage dividend discount model. Now, what is the first part over here? It is the same part which we have seen in the first part of the stock valuation video, where the dividend is growing at the same rate, G1 in this case, for T years. So for example, now there is a company with MissMolly.com, and its current dividend is $5, which is expected to shrink at the rate of G1 is equal to 10%. Remember, it's shrink. It's not increasing. It's shrinking at 10% for first 5 years, and then it will be growing perpetually forever at 4% forever, right? If the discount rate is 10%, we can simply use the previous formula to find the present value of the stock of MissMolly.com. So you have D naught, which was 5 multiplied by 1 plus G1. Now the growth is shrinking. So the growth means it's minus 10% now, shrinking. So 1 minus 10% will give you 0.90 divided by K minus G1. So the K was 10%, your required rate of return. In decimal, it's 0.1 minus into minus the G1, because the growth was shrinking, right? It is minus 10, it's not growing. And then we plugged in the other numbers, and this first portion will give us the present value of the stock coming out of the first T years, during which the dividend of this company is shrinking by 10%. The second portion will give us the present value of the dividend by which they were increasing by 5% perpetually forever. So after T years. So after T years means in T plus 1 year, T plus 2 year, T plus 3 year, forever, whatever the dividend they receive, they are increasing perpetually at the 4% at the 4% rate, and the present value of them will come from this second term. Some people might be confused with this, what it is doing. So if you see, can't we write this 1 plus G1 divided by 1 plus K whole raised to the power T as 1 plus G1 raised to the power T divided by 1 plus K raised to the power T? Yes, we can write it. So the first dividend, which is right now, it's not even a first dividend. This is a dividend right now, current dividend. Current dividend can be multiplied separately with 1 plus G1 raised to the power T to generate the dividend at the end of the first stage, where the shrinking was happening. In the first stage, shrinking of the dividend was happening for 10%, right? So at the end of the first stage, the dividend, the current dividend will grow to D naught into 1 plus G1 raised to the power T. And then we need to get the first dividend of the second stage in order to find the price of the stock at the end of the first stage. So this is 1 plus G2, right? If we'll multiply it, we'll get the first dividend at the end of the first year of the second stage. And then we can find K minus G2 to find the price of the stock there. And further, if we divide 1 plus K, we will be able to get the second, with the second expression, we will be able to get the present value of uh, the dividend of the second stage, and eventually we'll add the present value of the stock of both stages, stage 1 14.25 plus 31.78, and eventually the overall present value of the stock will be $46.03. You might be confused over here, so please pause the video and do this calculation by hand, and then try to understand how these numbers are coming up.